Okay, so this is question 5 of the mock paper, paper 1, and it's kind of an area question with a bit of functions thrown in, a little bit of substitution thrown in. There's a few things mixed in, so let's have a look. So it's telling us that we're dealing with a rectangular garden and that the fence from here to here and then back to here is 16 meters altogether, but we do know that this is x and this is x, so we just drew this out here of x here, but we don't know what this value is, alright? But we do know that the whole length should be equal to x plus what, 16. Okay? Or sorry, 16 minus 2x's. Did you get that? Because all of this is 16. Remember, we're not including this because that's the wall, not the fence. So the length has to be equal to x plus whatever this is plus whatever this is. So there's 2 x's. So to find the length, it's going to be 16 minus 2x. So I can say that the length here is 16 minus 2x. Okay? It's an arbitrary value because we don't know what x is, but that's what we're going to try and find out now, or in a few minutes. So let's have a look. It then says, show that this is in fact a representation of the area. Well, you know that to find the area of a rectangle, it's length by width. So in this case, area is equal to length multiplied by width, which is going to equal x, length is 16 minus 2x multiplied by width, which is x. Okay? And when you multiply that out, you get 16x minus 2x squared. And there's your proof that that is in fact the area. So on the axis below, draw the graph of the function ax is equal to 16x minus 2x squared. Now I didn't bother, I just thought I'd have this out ready to go previously. Alright, so just check it to make sure that's clear. So I'd say you've definitely been shown how to do these tables before. So I put the represent the function here, the actual function here, and the answer that you get here. So my x values, according to this, start at 0 and end at 8, and they include 0 and 8. So 0, 1, 2, 3, 4, 5, 6, 7, 8. It's a bit of grunt work. You only have to fill out one of these values, and then you can just sub in all this. But remember, lads, if you don't show some form of this table, you're not showing your work, and it could penalise you quite heavily. Alright, and in case you're not aware, you can do this on your calculator. So you turn the calculator on, go to mode, choose table, and you get a familiar looking f of x. And this time our f of x is 16x. So hit 16, then the alpha button, and then down here, see the red x. So alpha is in red, x is in red. So 16x minus 2 alpha x, and I just square that there. Okay? So now the calculator recognizes this is a function. Where are we starting? Well, according to the question, we're starting at 0. Alright? So we're starting at 0. We're ending at 8. Alright? And the step, well, we're going up in ones, aren't we? If you look 0, 1, 2, sorry, you can't see that. 0, 1, 2, 3, 4. So we're going up in ones, so you can keep the step as 1. Alright? Just might bring that a little bit closer. Okay? Equals, and there you have it there. So there's all your answers on the right hand side. Okay, so you can do that on your calculator. Handy, but again, lads, you cannot depend on the calculator. You have to be able to do these yourself. The calculator is a nice time saver, really, more so than anything. So now that I have my values, 0, 0 is here, 1 is 14, which is 2, 4, which is going to be here, 2 is 24, which is going to be here, 3 is 30, which is there, 4 is 32, which is there, and then it kind of follows the trend going like this. Okay, so there it is, plotted onto the graph. Make sure you join them up. It doesn't have to be perfect, but it does have to look like a negative quadratic. Okay, how do I know that's negative quadratic? Well, there was a negative in front of the 2x there. So there's the question drawn out. Okay, so then it says use your graph in part B to answer the following question. Oh, sorry, the ink seems to have cut it off there. I do think it says question, but anyway, estimate the maximum possible area of the garden. So he says to use my graph. So the max area is going to be when x is equal to 4. Alright, and I just show, go across at 32. Okay, So all you have to do is say 32 meters for that one there. Alright, so, oh yeah, actually go from 4 as well. Okay. So you can see from your table that when x is equal to 4, you get the largest value, and there it is. So bring it up across 32 meters. Sorry, 32 meters squared. Okay. So all you had to do for that one was write down 32 meters squared. Find the range of values of x for which the area of the garden is greater than 26 meters squared. So for that, you go to where 26 is on the graph. Okay. So there's 26, 20, 22, 24, 26, and I go across, and wherever it touches the graph, I go down. Okay. So it goes down here, and it goes down here. And this value is roughly going to be 2 1/3, and this value here is going to be 5 2/3. Okay, or 2.3 and 5.6. 666 goes on and on. Okay, so how would I write that as my final answer? I'd say 2.3, and that little dot just represents it's recurring, it goes on and on and on. Okay, is less than or equal to x, which is less than or equal to 5.6. Put a dot on top of it like that. Okay, so once x is anywhere between this value and this value, it's going to be larger than 26. Okay, and that's question 5.